Good morning. Okay, as the event title suggests and the title of my presentation, the IP verification challenges. So I'm going to talk about the challenges involved in IP verification, especially my experience working in Rambus. Uh, so as we know, the IP is very vast subject, and I think the challenges are different. And every project we do, I mean, they come with their own challenges. But just for this presentation, I've just kind of listed the challenges which we have faced very often in Rambus. Okay. So I outlined the presentation. So I quickly go over the IP introduction and the development flow. I really want to spend time on the challenges that involve, and then finally we conclude the session. Okay. A very simple definition of IP is parsing a design into a visual form is called the IP, but more sophisticated would be the parsing of the system into appropriate size component with clearly defined interfaces called the IP. And we have different kind of IPs like digital IPs that comes in the RTL form. Then you have analog IP, I mean the AMS mixed signal IPs. And then the programmable IPs, like either you have immediate one or the programmable FPGA one. Soft IPs, mainly the RTL one or written as very high abstraction level. And then you have the hard IPs. They are kind of fixed layout and highly optimized for particular or given process. Like hardware IP, software IP, design IPs, test IPs, and verification IPs. Okay. Just wanted to little bit talk about the differences between soft IPs and hard IPs because we mostly deal with these kind of IPs. Especially in Rambus, we have soft IPs and hard IPs. Soft IPs are generally in the RTL form, so they are highly configurable and customized, so they are flexible. So based on your application requirement, you have option to add or delete any of the features. And since they are tool independent, process independent, you can easily portable them, and they are highly reusable. In contrast to the soft IP, we have hard IPs. So they are like a fixed layout. They are fixed for particular design. They are fixed for particular application and process dependent. So they are highly optimized for particular process node. So that's the reason they are highly predictable because you have taped out, you have tested the IP, you have done the characterization, so you know the performance. So highly predictable. Since it has to go through a complete flow, right from spec to the silicon tape out, that's the reason the cost and the effort required is higher. Okay. So I think, yeah, it's very important the quality of IP for success of any SoC because the SoC is nothing but is the combination of different IPs. So IP design and verification is a very challenging job, as the historical data suggests that the most of the time or the resources in a given project is spent in verification. And the functional work are still the number one of the costs for the silicon respin. So really the quality of IP is very, very essential and very, very important for and if you miss out any issues and if you have compromised with the quality, then you will definitely have the implication of cost because of that one functional issue, you have to respin the design, and that going to cost you hell because it's one tape out would be like $1 million or more than that. So not only that your current the future plan, the next project also gets affected because of any functional issues. Your company reputation in the market with the customer definitely will drop and you will miss the time to market window. So delivering high quality IP in a is very, very important for success of any project. Okay. So this slide talk about the development phase of IP. Different companies company will define in different way. But in Rambus, we have this project definition called PD1, PD2, PD3, and PD4. So what they are essentially is the PD1 is where the conceptions, right? So where the marketing team comes up with the requirement, this is the, and then it goes to the engineering team where kind of they form the spec and say that this is how the IP should be defined. So get into a architecture spec. So that's the PD2 phase for us where the spec is finalized. We have to estimate the resource, schedule, and everything. And then when we exit to the PD2, we go to PD3. The PD3 is actually the execution phase where the implementation, verification, everything starts. And toward the end of PD3, we exit and we enter into the PD4 where we are done the tapeout, and then we have to release the IP to the customer, and customer support and everything starts. And also PD4, the chip is back, so we do the validation, we do the testing and characterization. Okay, so just one disclaimer here. So I have not listed the complete steps required for any IP development flow. Just wanted to show that where all the verification efforts are required. So I have listed a key steps here. So the specification is the first thing for starting the execution. So where both design team and verification team parallelly start. The design team start creating their microarchitecture. We start creating the verification plan, and then development cycles start. They implement the RTL form or whatever form they wanted to do. Because in Rambus we do have creating the design in form of very like creating behavioral model in system C and other things. But anyway, so the development parallelly start, and we develop the test bench, and then it goes to the formal verification, a functional verification. And then once we reach to a stage where we see the design is stable, then it goes to the physical design where they do the implementation, and then we have the gate level netlist, we start the gate, and then all whatever the metrics we have defined for functional verification sign now be complete, and then tapeout happens. And then finally, once tapeout is done, chips are back, then the validation starts, the silicon is done. Whereas we are busy on all this process, the customer is always like banging on us, and then we have to support on many of these phases. So we would be releasing into the model to them, and they have to integrate the model in their SOC or their simulation environment. We need to support them. We need to provide the right kind of documentation, whether it's integration guide or it's a user guide. If something is not working, we need to review their waveform, review the test case, and make sure it is up and running at their end. So definitely, it's a very challenging apart from doing this one, but handling customer is also a very challenging job. Okay. So just wanted to bring your notice here. Just before the tapeout, we have this verification that we are the last quality checkpoint for the design. So if anything is missed out, we are the responsible for that. So we need to make sure that the quality is not compromised, because after this, there's nobody who's checking. And one more important point for the verification engineers, that we don't have any tool that would certify that your design is bug-free, right? Unlike other tools, they say, okay, there is no timing violation or other things are clean. But here, you have to put all kind of manual effort, some automated process to ensure the absence of bug. Okay. So what are the different challenges involved in the IP verification? So I have kind of categorized into these challenges into 6 different items. And I'm sure that most of the people who are working IP, I think they also will face, or they have been facing such kind of challenges. But I think beyond that also you might have the different challenges. So first one is the input. What I mean by input is the dependencies. So we have a lot of dependency with the cross-functional team. So we wait for architecture specification, we have dependency on the design. So all this, if they are not coming on time, they are not complete, definitely that puts a lot of pressure on us, and the team has to go through the stress and other things. So that is one of the biggest challenge we face very often in Rambus. And the second one is the execution. So that is within us. So within the verification team, how we manage the verification, right? So that's very, very important and very challenging task. And the third one is the communication. The communication is nothing but setting the expectation with your internal customer and your external customers. The fourth one is the quality. I mean, we just talked about the quality, how important that, but it's very, very challenging. And the fifth one is the validation. So validation, some of the soft IP, they don't go through the validation, but I think they have some FPGA prototype or something, but they have to manage it. So that is also very challenging because now you have to work in different kind of environment. Apart from the RTL verification, now we would have a different environment for FPGA. And the last one is the customer support. So let's spend time to understand these challenges a little bit more. So as I discussed about the input or dependencies, the customer requirement, I mean, that is the very first, the input is required in order to define the IP. If that itself is not coming on time, then overall it impacts the complete schedule, and then definitely it's impact the verification also. So sometimes they comes on time, but it's not complete, right? So then we need to have the dialogue with them and then discuss, okay, you are giving this and we are giving this, but this is not complete. So all kinds of the design implementation and specific inputs. So I think I'm sure everybody would agree with me. Beside doing the black box verification, we also want to do the white box verification. We want to understand what are the different challenging or complex design blocks are there within IP that require special attention. And that is only possible if we have this information, right? And this information is there with the design team with some form of microarchitecture document. So that is definitely required. If that doesn't come, then there is a risk to the quality. The specification freeze, some point of time, I mean, architecture team has to freeze the spec saying that, yes, this is the final definition of IP and no more changes, because if you change anything, then it has to go through the complete process where the design has to be changed, your verification test tools has to be changed, complete environment is changed, so that impacts the schedule. Then feature freeze. Feature freeze is the stage where design team has implemented all the features. So it's like the design is a feature freeze, and that is very, very important because now you know that you can run all your complete test suite. Now, otherwise, like you are running and then say, okay, this feature is not supported, because of that you are getting this kind of error. So it's very, very important milestone. The next one is the code freeze. So that's the important stage where the no more bug would be fixed. They have to go through the issue change. And that is where we can, we are the person who say that, yes, we have reached a stage where we are not finding any functional anomalies or bugs. So design is very much stable. Now it has gone, can go to the next stage where the implementation and we start verification gate level and SDF form. And some of the IPs, they also have the element like third-party design, third-party model and VIP. Interestingly, in the current IP, we have a memory controller coming from third party, and our customer want that has to be tested out or verified in the test chip level, because the PHY they are going to kind of have with the particular memory controller. And since this is a very early specification, so we have challenged the memory controller itself is not completely verified. Where our PHY is also in development phase, and then the memory IPs which we are talking about from Denali or different worlds, like we deal with every or other vendors, they are also kind of in development phase. So these items also bring a risk to the program because once some issues are there, we are not sure whether issue is there in our verification environment, is there in the design, or these third-party IPs. It's very, very important. I mean, these are the input and these are the challenges to the verification team coming from outside. And this slide talk about what are the challenges we have within the verification team. I would say that the schedule predictability at the manager level, if I have to talk to management, talk to cross-functional team, I should be able to tell how much we are done and how much is left out. So that is only possible if I some way can quantify the effort and say that, okay, this much is done and this much is pending, and how much effort is required. And that is very, very essential. So for that, there is no tool. I mean, you need to create your own process and identify or have that thing so that you can quantify the effort. And I divided this overall execution in three phases. First is the planning, the second one is the implementation, and third one is the verification. The planning phase is where we develop the verification plan. So that is very important because at this stage, we should ask ourselves, how complete is our verification plan, right? Are we complete? In order to say that, or in order to verify the completeness and the correctness of design. So these two keywords is very important. The completeness, when I say, is basically your coverage. And using that, you are going to say that if I cover these things, I'm done. So the completeness has to be there in the verification plan. And with that, you can say 100% surety that you are done. And correctness is when you have this automation in your environment, all kind of checks has to be there, and you have not missed out anything. So you need to have some kind of flow where you can extract all the features, and you can correlate that every feature I have checks, and for every feature I have coverage. For every check I have coverage. For every coverage I have check. So it's just a little bit tedious job, a manual effort. Sometimes there is some automation, but it's very, very important for you guys to have the flow in order to quantify that your planning phase. And the second one is the reuse, because apart from the quality and efficiency is also very, very important. Productivity is also very, very important. So you need to give a real thought at the planning phase, how much you can use from your legacy project, how much you can use within the project, across the project. So I think that's very, very important. What reuse you can give to your future project. So that's where, and also it will improve your quality, because something you're using from legacy, it means that it has gone through the production and quality is already there. Third-party VIP models, I think that is the essential phase. Now it's the current challenge I have is that since the model is not stable, so I can't rely on single model. So I have at least 4 models from 4 different vendors. And then we are working with them. Some people we have a understanding like partnership. Since you are developing, we are validating. So we are working with them in development phase. You give it us. And since I'm standing here in Karen's office, so we use the Denali, but their development time is huge. Any bug or any issue we found, I think they take a week's time or so. And because for them, we are not only the customer, they have different customers. So we need to have somewhere where we can quickly fix it, because any issues we want to, expectation is that it should be end of the day, should get fixed. So we need to have such kind of partnership. We can directly work with R&D team. And that is only possible with you when you can work with some vendors which is not there stabilized in the market and other things. So I'm just talking about that so that you understand there is a risk and you have a backup option for that. The second phase is the implementation. So here I think what you have planned, and then finally your team is going to implement. So it's very essential for you to know how much implementation is done, how much is left out, right? And that is again it's not everything you can automate it, but there is a way you can automate. There are tools available, but it's all depend on your methodology and process what you are using. And that's the reason it's very, very important, because it's within your own control, and then you can define the process methodology. But you have to have some way where you can define uh, a verification to implementation, you have not missed out anything. Life of code, I mean, that's very, very important. And I think when I was engineer, I mean, first thing, as soon as you give something, people start darkly coding. They don't want to spend time in documentation, don't want to understand that whether this particular code would work with all kind of scenarios or not. So that life of code, because we are the developer, so we are giving the life of code. We should certify whether this is 10 for a day, month, a week, or complete cycle of project, right? But I have seen that people often, like, next day you see that they are changing code, next week they are changing code, and they spend a lot of time there. That is because they have not spent time in the planning. This is very, very important, very, very challenging. So the engineer has to think, because they are developers, so they have to give the life to the code, and they should know that how many days life I'm giving this code. The transferability. Now we are working in a world where there are very challenging jobs. We have many designs, and currently, if I see that this month we have 2 tapeouts in November. Implementing your code is such a way that people can understand and they can modify, maintain it, because that's very, very important. And it is required, and it's very challenging thing, because you might have a challenge where one of the key engineer leaving company in between the project, and you will find that, okay, what he has written, nobody is understanding. So please make sure that you take care of these 2 things also. Okay, the final phase is verification. So all these things are fine because you are developing an environment, but you have not done anything to the design. So finally, you are going to verify the design, right? That's important. That's going to tape out, and that's going to give you the money. So here, I mean, your all focus would be on the implementation to result and what you have implemented, whether that is seen in your result or not. You have all the coverage, whether you have achieved 100% or not. And I just wanted to bring it because there is always confusion between the code coverage and functional coverage, right? So as a verification engineer, your all effort is to see that the intent of the spec is maintained in the design or not. And code coverage doesn't give that. Code coverage says what design has implemented, whether I have covered or not. So happen design has not implemented something which is there in the spec that you will never catch. Beside other differences, what I'm talking about. So our always references to the specification. So yeah, code coverage is important, but it's not sufficient. So that's the reason you have to make sure that the planning phase we are talking about, you have to extract all the features, and you need to have the coverage for all this. So next one is the debugging. I'm sure you would be agree that the most of our time goes on debugging. Most of the time. So even like I would say 60 to 70% time which engineers spend, it goes in the debugging. And why it goes? First of all, there is no tool which is mature enough. You know, and earlier we had the scope and other thing, and then finally the waveform. I mean, that is the only way you have. Beyond that, EDA company are not evolved to come up with some debugging tool that would help you or basically reduce the debugging cycle. So I think that's a very challenging job, but I mean, you guys can see how you can help and reduce the time while having a good logger or kind of having a tool which is better than other tool. But I think this is definitely one of the time-consuming things, so that you need to plan it. Progress tracking and quality check. I mean, definitely you have to track it. I mean, if you have data, you can analyze it. If you don't have data, you are not going to analyze. I mean, so as I said, right, you need to quantify it, and the quantification happens when you have the data, and it's very, very important, right? So your progress, your status has to be tracked, and then that's basically you have to define the milestone where you are going to do your quality check, and make sure that you do the quality check at the right point. Okay, the next phase is the communication. So as a verification team, I think we are the support team. So we have different stakeholders: architecture team, design team. There are the teams like your system engineering team, which we are going to do the validation. So I mean, especially in the members, we have a different team. But the important is that how you are going to manage the communication with these different stakeholders and making sure that you are meeting their expectation. Because their progress also dependent on your progress. So it's important that right kind of status is given on time to them. Collaboration with the architecture team and design team is very, very important. I mean, if you work in isolation and say, okay, there is a spec and I will work, and then there is no communication and interaction happening, I think that's very dangerous to the quality of design. And you need to be always in the collaboration mode with these people, because architecture team has so much information. They are talking to the customer marketing guys. So it's important, and also it is very important if you have make any assumption. It's very, very important for verification engineer to clarify all the assumptions, because if assumptions are not right, it might encounter some quality issues. It's very, very important, and have a dialogue with architecture team and design team. And some weekly, monthly progress, I mean, depending on how you work with them, I mean, that has to go on time with the right kind of information. Your verification plan has to be reviewed with all the stakeholders so that you get all the input and what people want is there. The anomaly report is basically talking about how the design is stable, whether design is stable or not, so that the curve, when you put it, it will say that, yeah, whether your things are converging or not. So it's very, very important to have such kind of report. Another report like your regression, coverage, and all, so that will give you the idea where are you in terms of doing the final sign-off or not. The verification report are different milestones, so I think that's also very, very important to give a sense to all the people and management that how you're making progress and where are you. Okay, quality and sign-off. So I don't have to talk about much about on the quality, but this out of spec verification. So we always think that the spec is golden, and what is there in the spec, and if we verify, we are done. But that's not true. Now that's the reason I always say, talk to my team and say that you need to always think out of box. Think what is not in the spec. That's the reason it's important to have dialogue with the architecture team and design team. And beyond that also, if it's possible, you talk to your EDA vendor how they are doing things differently. Same design, how other competitors are verifying. It's very, very important, right? Today I'm here because I wanted to talk to you people, understand you. Basically, I'm met with Shyam, and he discussed me about this, and he asked me to give a presentation 6 months back, and I said yes, and then finally I'm here today. But what I'm trying to say here is that your communication with the external world is also important, because if you feel that what you have, the flow and process or methodology, that's good enough, then you will have such kind of problem. So I'll give you one example here. So we have 1.5, which is the DFI compliant. As per the DFI, if you're familiar with the memory protocol, the read data comes in the bus. So this, so it is like, so the read, when you give the read to memory, the data comes back to the PHY, and PHY has to give to memory controller. And as per the spec, you can give the one D word, that's enough, and then across the D word you don't have to align. That's memory controller job. It's good. As per the DFI, it is good. But other competitor, or other 5 vendors, they are giving the data with a line. And so it's easy for memory control team not to implement that logic, because if you have a big data, which is like 128 byte and other thing, that involve a lot of area and other thing. So, but as we are compliant with the spec. We can say that we are compliant with the spec, but our design is not flexible. And if you do that, you are not out of spec compliant, but that is something, and that only comes when you understand how other people are doing and how is their interface to the user. So it's very, very important. The interoperability. So as IP, we say that IP is reusable, and the expectation is that it should be plug and play, right? It should not have any kind of interfacing issues. So most of the IP, they have the standard interface or some proprietary interface. But how do you know that whether that is what you understood the spec is the same way other competitor or other vendor understood? Unless you do the interoperability exercise where that, let's say I'm developing PHY, so I need to interoperable it with different vendors, memory controller, ensure that it's working fine. So it's very, very important for the quality point of view. Certification from a standard authority, because some of the protocol it's very, very important you get certified with a standard authority like PCI Express, you have PCI 6. So you have to go there, take your design, and they have compliance test shoot, run that, and they will certify that you are 100% pass on that. So that's really required. Demonstrating the absence of bug. I mean, that is your gut, I mean, whether you have reached this stage or not. And then only you can say that, yes, now you can sign up and I'm certified that this IP is bug-free. Schedule versus quality. I mean, as we said that we have dependency from different functional groups, and in my career I have not seen that all the inputs comes on the right time. So that's one of the challenge. And also if they comes on right time, they are not at the right quality or not complete. So we get, because we are the last quality check, means everything get delayed, we get compressed, and then finally we reach a situation where the 4 weeks effort or work we need to complete in 2 weeks or sometimes a week, right? So there is a compromise between schedule and quality. So how do you manage that? And that's also one of the important challenge, and then that you have to manage, but don't compromise on the quality. You might be encounter such a situation, but never compromise on the quality, because tomorrow if there is any issue, and you would get blamed, right? Or if you have to do, make sure that you kind of clearly listed that and highlight to management, if I'm not doing these things, and these are the risks. So very, very important. Okay, on the validation side, so especially in the Rambus, we have this mixed signal IP, so we always do the validation silicon tape out. But some people who are working on soft IP, so they have the FPGA prototyping and also they do at this stage. The problem with that FPGA and other thing is because now you have to develop two flow. One is for your art, and because FPGA, not sure everything you can run on the full speed, and also sometimes you need to create a RTL or modify RTL that is very specific to the particular FPGA to meet just timing and area touch and other things. So then you have challenge to maintain two flow. And we sometimes we do have, because we also have some SerDes IPs, and then where our PM is a hard IP, but PCS layer is fully digital, and that has to be kind of certified by the PCI 6, because we have IPs in PCI. So those things we have to take it to the FPGA level, where we have to work with third party and IP, and then this, I would say, like this is very tedious job maintaining a two environment, and then many times this environment come from our your partners and all, and very difficult because especially on these kind of things we use third-party IPs like Mac IP and all, so it's very, very challenging. So you need to understand what kind of validation you are doing and how much effort that requires. Importance, why it is important, provide high confidence on high quality, because now what has been verified RTL, now you can see the silicon is working or not. So beyond that RTL also you can find any issues are there. Discover any issues that can be found in RTL Pro, definitely. Third-party interoperability and protocol compliancy. So once that is done, you have high confidence, because what your IP is working with the third party, it means it's a plug and play, right? I mean, that's one of the expectation we have from the IP. That's a part of the IP definition. Reuse from verification to the validation. I mean, again, this is also very important. So the design, what we are verifying in the RTL form, and same design in different form, whether it's FPGA or silicon, right? But that would be tested by different team. But can we leverage the effort we have put in creating the test environment, creating the test sequences, but in different form of. So they may not be using system Verilog, whereas you're using system Verilog. But if you develop a flow where you can convert your test sequence from system Verilog to a test vector, whatever software using, I mean, that definitely add a lot value in terms of the quality and efficiency. And we have done a lot of work on this particular thing where we could generate the documentation out of it. We can generate the firmware. We can generate the complete test vectors. And if somebody modify the test vector, we have ability to come back and convert that to system and run the simulation. So, but I think that's very, very important. Managing different verification environment, definitely, if you have such kind of things like how do you manage? Because that's even we have challenge. We have the model, which comes much early when the spec is not mature or finalized. Then we have design, which comes kind of quite late, but by that time the spec is mature, right? So there are certain things which we can't implement in the behavioral model, especially those analog or custom logic things that is written very high level of abstractions. And similarly, we have the FPGA flow and other things. So managing different environment also is very, very challenging. But ensure that you make sure that you have single environment so that it's easy to maintain. Because otherwise, what happens that if you don't give the priority, then if you look after a couple of months, then you see it's a lot of work and things has to definitely you can't manage it. IP certification and qualification. So that is very, very challenging, especially for Rambus, because we are the patent licensing company. And these, all this standard authority has a clause and terms and conditions that won't allow us to sign their contract and become a part of those standards. So then, if we have IP, which requires the certification, that's very, very challenging because we can't go directly to there and then do the qualification. So then we have to look for some partner, and those who have this environment and work with them. So that's bringing a different kind of challenges to us. Okay, customer support. As I said, while we are busy and doing all the verification, the customer is always sitting on head and asking different kind of information, releases, and all those things. So I think you need to plan it so that you can manage this challenge. You need to have dedicated support who is going to interface with the customer. So that's very, very important, so that the one person, so it's easy for customer also to understand if I go to this person, all my problems are resolved. Actually, customer doesn't have to go to different team or different people. Integration guide, how easy your verification environment or your IP to the customer, they can easily integrate at their end without your support. Right? So that's the important or the key item when you're developing such kind of collateral. So you have to make sure that you have the user guide which has all these FAQs related to things so that they can refer and they can do that. Issue tracking system, I mean that's also is important. I mean internally you will have a different tool, but when you are dealing with the external customer, how you are tracking all the issues. And you need to define some kind of worst case and best case resolution time so that the expectation is set. And also it's very, very important because if you screw up here and it get easily escalated to the next level, it directly go to your maybe like head of the company or sometimes go to CEO. So you don't want to have such kind of wrong things. So you have to be extra careful when you are dealing with the customer. Okay, so I mean you require support when there is IP integration, there is simulation bring up, and we have challenges where we have to not only support customers, but we need to support customers to customers. So think about that, how tough that would be when we are developing the IP at the same time, so the multiple customers are doing integration with our model, where still things are development phase. Okay, so I think I have kind of talked about the challenges which we often face in Rambus. Kind of given the little bit insight from my side, but just concluding, what we could do and what we are doing in Rambus. Not everything I've listed, but few suggestions are there and I'm sure they would be applicable to you when you are doing any kind of IP verification. Define and follow the standard flow process and methodology is very, very important to have the process, to have the flow and methodology developed for all this kind of challenges, the issue we face, so that, and make sure that it is process driven everything. It's not a person driven, because if you are relying on the key engineer, and if that engineer is moved out, some reason either due to attrition or it has to go to some other project, then you will have a problem. So make sure wherever possible, your all the execution should be process driven, not the person driven. So if you understand this one, then your mindset is different. You will always try to do something which is process oriented, more on automation. So that is very, very important if you have to deal with IP verification. Always strive for quality and efficiency. I mean, I talk about that, don't think that what you have up, you're having that UVM and SVM, you say, okay, I'm the best in class. I mean, no, I mean, these are the tools you have, but how you are going to utilize is very, very important. For that, using this tool, you have to create the environment. Using all this resources you have available to you, you need to create the process, and then always think about the quality and the efficiency, because efficiency is also very, very important, right? Today, if you have completed a project with 10 verification engineers, the management expectation is the next such kind of project you are going to do with 6 engineers or 5 engineers, right? So how do you quantify that? So that's the reason it is very, very important. When you have the process, you can generate the data, you can analyze it, and you can quantify it, and you can predict the quality. Set right expectation to your customers. So whether your internal customer, external customer is very, very important. I mean, you need to set expectation. Otherwise, many times we see the communication, and sometimes your team might be doing very great job, but that is not seen by other groups. And why? Because you are poor in communication. You have not set the right expectation. It's very, very important, especially with your external customer. And I think the same thing is true with internal customer also. Be proactive and drive the execution. I mean, that is also very, very important. Many times we have seen that we are support team and then we are driven by other team. No, it's not true. I mean, before somebody asks what is the status, where are the issues, what are the risks, I mean, you should tell that. That's the reason I told you in communication, right? The weekly, monthly, whatever you have, you should be telling that, okay, this is what I've done, this is not done, this is the risk. Another thing, and I'm waiting for this input. If this input not come so in time, this is the risk. So what happens that the people start following other people. You are not given this thing. So now you see, just because of doing this one, you are driving the overall execution. You are not driven. So little bit mindset, and then you will see that how you can manage the challenges. Document everything. It's very, very important, because because if you see that all things happen through the email, and because we work with a remote team, and as I think introduction you talk about that I'm managing the global verification team, it means that we are responsible for the worldwide verification. So we have 4 or 5 remote teams in the US. So most of the communication happening over the email or the phone, right? So it's very, very essential for us to document each and everything, even minor thing also. We don't make any assumption. If any assumptions are there, we get clarified. If we suspect, I mean, even we are not getting right answer to our from our architecture team, design team, will go to our competitor part, and we need to generate some data and see how they're behaving and compare with that, and go back to tell to the architecture team, this is what we are expecting, but our competitor part is showing this result. Let us know what you have to do. And because, as I said, out of the spec is very, very important. Many times JDEC spec is not clear. I'm talking about my challenges because we work on memory side, and some of these specs are not really clear. And that is one of the drawback, because whoever developed first solution, and then they kind of complete ecosystem and environment is developed. Because of that, the early word or early customer or your computer. So it's depend on that your computer how well he understood the spec, and based on that complete system software is created, BIOS is created, and then you go and then you integrate your system. It's not booting up. and then say, okay, this is how completed part is doing, your part is not doing. Even you say that you're compliant, but sometimes you have to go out of the spec and then have to say that, no, I'm also working with your wife. So beyond that spec also very, very important, beyond your RTL verification is also important to do some kind of system level verification and sometimes real-time verification. As I said, right, the FPGA prototype, what we are doing is we are kind of doing with the standard software or real-time verification. Don't compromise on the quality. It's very, very important. You would be encounter a situation where you have to compromise, but make sure you document, clearly specify, and highlight the risk if you are going to compromise on the quality. That's the essential thing. Okay, I think with that I want to conclude my session, but I think definitely if we can manage all these challenges, we can deliver the high quality IP in short time market to window. That's my message to everybody over here, and all the best. Thank you. Thank you.
Do you have any questions for the next?
Yeah, sure.
Microphone.
Okay.
Hi, I'm Sudhakar from IBM Semiconductors. I have few questions regarding the challenges that might not have mentioned in this thing. While you are building up your verification environment and flow, process, and methodology, have you faced any challenges in adopting formal verification for verifying your designs and sign off? That's one question. Okay.
I think I mentioned that the second point. So the question was on that, have you faced any challenges while doing the formal verification? Is that correct? Yes. Formal verification adoption. So I think it's very, very important for us to know that the internal or what is there inside the design. Design implementation spec has to be there, which we call as the microarchitecture team. If they let us know what are the key or complex logic within the design that require extra attention or the formal verification, because formal verification nothing but the white box verification, and it's require a little bit more documentation than generally we do, because when you are doing the formal verification you need to have the clearly defined the interface so that you can put your constraint. So definitely we have faced issues when we were doing the memory controller, because that has a lot of arbitration logic and other things, and we need to work with design team closely. But generally for this 5 IPs and all those things, I think we are not doing the formal verification, but we have worked on that. We have faced many challenges in terms of the tool capacity, and when things are not converging. So that kind of tool-related issues and the design-related issues where they have to modify the relay design to make sure that, because that's important for them also. Because if you have a bigger FIFO and bigger FSM and all those things, tool can't support. Other challenges with the design team is that not having the proper documentation. So we need to work with them, and it is good if you can start that very early development phase. But once your functional verification is started, then it doesn't have much value unless and otherwise that is not getting verified in your black box verification. On the formal verification? Oh, in general. Yeah, I mean, we face, I think, daily basis problem with the tool, and I'm sure you guys also face. The biggest challenge I would face with the tool is the gate level and SDF simulation. The time taken by them is very huge. And we work with them, and every project we say this is what is there. We give them data. They'll come up with some switches, the patch release and other thing, it gets improved. And we generate the data. Now it is improved by 30%, but next project we'll have other challenges. So that's always a problem in terms of the simulation time. and sometimes whether we have bigger dumps and other things, so that also the tool crashes and all. So that's mostly the tool stability point of view. Sorry, I didn't. Right. So I think the equivalence check is done basically by complete flow on by the design team. They do, because as I told in one of the phase where that once we reach to the code freeze, where any changes would go through the ECU. So they'll do any kind of changes that we do through the this formal compliance check. But we don't rely on completely on that. We still do the gate level and SDF simulation. So that is there, but that's not the complete. So we also do the SDF simulation. Does that answer your question?
Any other questions?
Sir, in inputs you talk about feature freeze and code freeze. So basically, when your design team and verification team in parallel, they start working together, and if you find some changes in code or some specification, how you deal with those kind of situations, like when your verification team is accelerating and you find some changes in your RTL design part. So how you deal with those kind of situations when you think you have freezed it with like 100% sure. So in that case, how you deal with it?
Yeah, these milestones are defined, but they are really. Yeah, so these are the important milestones we have defined by the PMO, but nobody uses. I mean, we have to go this kind of challenges very often every project. We never reach the stage where the spec is freeze your feature or the design is feature freeze on time. So that's the, as I said, right, these input get delayed. That means the excuse, I mean, kind of compress everything toward the end of tape out. So we need to deal with them, put a lot of effort toward the end of tape out. That's the reason people have to release log, work day and night to complete on all those things. Wherever possible, we escalate those things to the higher management level, and but I mean, there's no solution to that. And it's important because they also have a reason why things are changing. It's not just like that. So the customers have given the last minute, or we have found some issue that is really required. Design has to be changed. So it has to go through that too. And many times the tape out might get delayed because of that. And if you think that no, we can't complete the sign up in 2 weeks time, and then the management has to take a decision, and they have to delay the tape outs. But the key is that don't compromise on the quality. These are the challenges would be there. You will not have the ideal situation where there won't be, where everything coming on time. So that's never been, I haven't seen that situation. Okay, thank you.
Thanks, Dinesh.